Hello! Hi everyone! Today, you and I are going to have a look at Introduction and Synthesis of Carboxylic Acid Derivatives, Part 1, Ester and Acyl Chloride. Ester are derived from carboxylic acid that contains C double bond OOH carboxyl group, where the hydrogen of the group is replaced by hydrocarbon, also known as alkyl group like ethyl or methyl. This may also be a benzene ring called phenyl. Ester have a pleasant aromas such found in banana oil, that is phenyl ethanoate, or isobutyl methanoate found in raspberries. Hence, ester are widely used as flavoring agent. Other examples of ester are fats and oil. Acyl chloride is also described as acid derivative, where the hydroxyl group is replaced by halide, namely chlorine atom. This acyl chloride is also known as acid chloride. It is derived from the reaction of carboxylic acid with acid chlorides of inorganic acid. Now let's have a look at the mechanism of ester. Step 1. Acid-base reaction. Protonation of the carbonyl makes it more electrophilic. Step 2. The oxygen atom in alcohol functions as the nucleophile. This nucleophile attacks the electrophilic carbon atom in the carbonyl, with the electrons moving toward the oxonium ion. Step 3. An acid-base reaction. What happens here is the deprotonation of the oxygen atom in the alcohol atom. Step 4. An acid-base reaction. In order to make the hydroxyl group leave, protonation takes place so that it would be converted into a good leaving group. Step 5. The electrons of an adjacent oxygen atom in a water molecule push out the leaving group. Step 6. An acid-base reaction. Deprotonation of the oxonium ion reveals the carbonyl in the ester product. Mechanism of acyl chloride. Steps to mechanism of acyl chloride. General reaction. First, replacing the hydroxyl group using phosphorus 5-chloride. Phosphorus 5-chloride is a solid which reacts with carboxylic acids in the cold to give steamy acidic fumes of hydrogen chloride. It leaves a liquid mixture of the acyl chloride and a phosphorus compound, and phosphorus trichloride oxide, or phosphorus oxychloride. The acyl chloride can be separated by fractional distillation. Let's take an example of ethanoic acid reacts with phosphorus 5-chloride, which gives product of ethanoyl chloride and phosphorus trichloride oxide and hydrochloric acid. Next is replacing the hydroxyl group using phosphorus trichloride. Phosphorus trichloride is a liquid at room temperature. Its reaction with the carboxylic acid is less dramatic than that of phosphorus 5-chloride. This is because there is no hydrogen chloride produced. Let's take an example of ethanoic acid reacts with phosphorus trichloride. We will end up with ethanoyl chloride and phosphoric triacid, or phosphorus acid. It is also known as orthophosphorus acid. Again, the ethanoyl chloride can be separated by fractional distillation. Finally, replacing the hydroxyl group using sulfur dichloride oxide. Sulfur dichloride oxide or thionyl chloride is a liquid at room temperature and has the formula of SOCl2. Traditionally, the formula is written as shown, despite the fact that the modern name writes the chlorine before the oxygen because of alphabetical order. The sulfur dichloride oxide reacts with carboxylic acids to produce an acyl chloride, and sulfur dioxide and hydrogen fluoride gases are given off. Example, ethanoic acid reacts with thionyl chloride, will give off ethanoyl chloride, sulfur dioxide, and hydrochloric acid. The separation is simplified to an extent because the byproducts are both gases. You would obviously still have to fractionally distill the mixture to separate the acyl chloride from any excess acid or sulfur dichloride oxide. That's about it. Hope you enjoy. Bye!